Hi, welcome to Engage New York Module 4, Lesson 17. Let's go through the concept development together, which is, the lecture, the lesson. So our objective in this concept development in this lesson is to relate decimal and fraction multiplication. So we're going to make a connection between decimal and fraction multiplication. So let's go ahead and begin with this problem right here. 0.1 or 1/10 times 4 is the same as 1/10 of 4, right? So now let's take our decimal and let's start to relate it to our fraction. So 1/10, if I put 1/10 as a decimal into a fraction, it would look like 1/10 times 4, right? So it is the same as 1/10 of 4, or 1/10 times 4. This is also like 4 copies of 1/10, right? All right, so if we write, so how would we answer that? What would be the solution to 0.1 times 4? Well, it would be 4/10, right? It's 4 copies of 1/10. 4 copies of 1/10 is 0.4, right? All right. Here's an example of looking at it in a place value chart. So what is the difference? Why did the 4 move? So here's 4 ones, and it's 4 copies of a tenth. It's 4 copies of 1/10. So when we compare the 4 ones that we started with to the product that we found, 4 tenths, we place a 4 here and in the ones, and then we have 0.4 or 4 tenths, right, on the place value chart. So what happened to the digit 4 when we multiplied by 1/10? Question, why did our answer get smaller? Well, this is like 4 copies of 1/10. There are 40 tenths in 4 wholes. There are 40 tenths in 4 wholes. 1/10 of 40 is 4. The unit is tenths, so the answer is 4 tenths. The digit stays the same because we are multiplying by 1 of something, but the unit is smaller, so the digit 4 shifted 1 space to the right. The answer is 4 tenths. All right, so let's go back to module 1, if you will. What do we remember about a decimal? Multiplying by 10, 100, or 1,000. So anytime we multiply, you multiply a whole number by a number, or let's say a decimal, by a decimal smaller than 1, comma, your solution or answer will get smaller. So you're multiplying by a fraction. Remember, a decimal is a fraction and a fraction is a decimal. So what happens when you multiply a whole number by just 10, 100, or 1,000? We're not multiplying by a decimal. Here, we were talking about multiplying by a decimal. But what happens when you multiply a whole number by 10, 100, or 1,000? Do you remember? Can you write it? when you multiply a whole number by 10, 100, or 1,000, your number will get 10 times bigger, 100 times bigger, or 1,000 times greater or bigger. So when you multiply a whole number by 10, your number gets 10 times bigger. When you multiply a number by 100, your number gets 100 times bigger. When you multiply by 1,000, your number gets 1,000 times bigger, right? Right. So let's move on. What about 1/100th of 4? What is 1/100th of 4? Remember, the of is really a multiplication sign, right? What does it do? Can you multiply and show me? What happens right here? What is the solution? What is the answer? It's the same as 4 times 1/100th of 4 is 1/100th times 4, right? It would be 4 over 100, which is the same as what? 4/100ths, right? Okay, apply that same reasoning to 1/1000th of 4. What would that be? We know it's a multiplication sign, that of is. It'd be 4 over 1,000, right? Which becomes what? 0.010 hundredths thousandths, right? 4/1000ths. All right, so now when you multiply by a number less than 1, your number, your answer, your solution is going to get smaller. Now, we've learned that when you're multiplying by a tenth, it's like 1 over 10, right? 2 times 1 over 10. Your decimal really starts right here, right? That's where this is the whole number 2. And when we multiply by 1/10, we're going to move our decimal over once, right? Because it's really 1/10 times 2, which is 2/10, which is 0.2. Are you following? All right, what are you going to do here? 0.01 times 6. Where does his decimal live on that number 6? Well, he lives right here, right? Because it's a whole number and 6 is a 1 unit, and it's right next to the decimal point, correct? So when we multiply by 1/100th, we have to move it once, twice, right? Because this would really become 6/100ths, which is 0.06, 6/100ths. All right, moving on to the next section. We're going to also look at using those 100 charts. Now, I don't think it's necessarily, I don't know, you have to use this 100s chart to show that your understanding of this. So it's just kind of going back to what we already know when we were sectioning off the area models. So this is kind of like going back to an area model, but you don't necessarily need to use it. It's just there as a visual to help you understand what you're doing. So let's look at this problem right here. 1/10 times 1/10. So 1/10 times 1/10 is really 1/10 times 1/10, right? So 1/10 times 1/10 is 1/100th. And 1/100th as a decimal, what is that going to look like? So here is our decimal. Here's tenths, hundredths, right? So we just solved that. And if you did 1/10 by 1/10, if you multiplied here using 0.1 and 0.1, you get 1/100th is colored in, is double shaded. Remember how we would shade in here and then you'd shade in again, double shaded? That's what it's showing you. All right. So let's just look at this really quick in a multiplication chart, in a place value chart. So here is our ones, right? I don't think we need that. Then here's our 10th. And here's 100th, right? All right, write that down. And let's see if we can show this. Okay, so when writing 1/10, where do we put the digit 1? You're right, in the 10ths place, right? In the 10ths place. All right, so what happened to the digit 1 that we started with in the 10ths place when we took 1/10 of it? So now we're going to take 1/10 of 1. What's going to happen to it? 1/10 of 1. Well, the digit shifted one place to the right. So now this digit is going to shift one place to the right again. So we are taking a part of 1/10. So the answer is smaller than 1/10. It makes sense that the digit shifted to the right one place again because the answer even got smaller. So it's going to shift, our 1's going to shift here, and our new answer becomes that, right? All right, so we're shifting again. All right, moving on to the next problem. All right, what will happen to the digit 2 when you multiply it by 1/10? What will happen to the digit 2 when we multiply it by 1/10? So what do you think? Again, it will shift one place to the right. So every time you multiply by a 10th, no matter what the digit is, the value of the digit is going to get smaller. The 2 shifts one place over to the hundreds place. So you know what? Let's just draw out a place value chart really quick just to model this. So if here's our ones, here's our decimal, here's our tenths, here's our hundredths, right? All right. So we have 2/10, and now we're going to multiply that 2/10 by 1/10. So because I'm shifting, I have to shift it, and it's going to become 0.02 200ths. So if you look at it here on a place value chart, or if you look at it here, 2/10 times 1/10, 2/10 times 1/10 is 2. 2 times 1 is 2. 10 times 10 is 100. It's 200ths. So our answer is 0.02. So then if you looked at it this way, 2/10, so if you had 2/10 here and 1/10 here, or vice versa, so how many would be double shaded? It's 2/10. All right. How did that go? All right, so our answer or solution is 0.02. Now, let's move on to problem C, right down here. If we were to show this multiplication on a place value chart, visualize what would happen. What do you think would happen on a place value chart? Remember, this is 1.2 times 1/10. So again, here's our ones, here's our tenths, and you can either write it like this or write it like, right? Or, oops, sorry. All right. So what would it look like if we have 1.2 times 1/10? Well, we would have 1.2, right? And now we're going to shift it 1.2 over by 1/10, right? So this is really 1 whole plus 2/10, right? So this would become 1 2/100. So let's move this over. It's really moving over. Everything has to shift. So we're going to shift that 2 over by 1/10. And we're going to shift our 1 over by 1/10. So our answer is, so 12/1200, right? Or 1 2/10 would become 1 and, oh yeah, it's got to shift. So this is 12/100, right? 0.12. This is 0.12. Did you see the shift? All right. Let's see. I'll give you a second to look at that. So the shift is over once. It's going to shift once because you're multiplying by a decimal by 1/10. There's one number behind the decimal, you're going to move it one time. If there are two numbers behind the decimal, you move it twice. If there are three numbers behind the decimal, you move it 3 times. So here's our decimal right here, and we had to move it one time over, right? Trying to show you in all the different ways that we've talked about. Okay. Problem. There's 3 parts of problem 3. All right. So we have 1/10 times 1/100. So what does that look like in a fraction? Well, it looks like 1/10 times 1/100, right? So what is 1/10 times 100? Well, it's 1/1000th, right? All right. So if you had to use this to model, you would have to cut one of the tenths up. So this model, if I showed you 1/10 of 1/10, which is 1/100th, we just solved 1/10 of 100th, which is 1/1000th. So if I had to draw it, I'd have to cut the whole vertically into 100 equal parts and just shade one. Then I have to cut just one of those tiny parts. Just one. Remember, if we had to cut one tiny part, that's right, we'd have to cut, then we cut just one of those tiny parts horizontally into 100 parts. Oh my gosh. So if I did the rest of the parts, I'd end up with 1,000 parts. So if I had to cut that up, it would be a lot of parts, right? And that would be a lot to work with and try to keep track of. So it would be like taking one tiny hundredth and dividing it into 10 parts to make thousands. So that would be really difficult to do. So I don't recommend that. So put 1/10 on the place value chart. Let's make a place value chart. Let's add another section. Those are ones, tens, hundreds, thousands, right? Okay, put 1/10 on the place value chart. Okay. Now, and I have to find 1/100th of this number. So the digit will shift in which direction and why? So the number will shift in what direction and why? It will shift to the right because the product is smaller than what we started with. Another question, how many places will it shift? Well, it's going to shift 2 places, right? Why 2 places? Well, we shifted 1 place to the right when multiplying by 1/10. So it should be 2 places to the right when multiplying by 100th. Similarly, when we multiply by 10, like just a number 10, a number by 10, the number shifts 1 place to the left and 2 places to the left, and when we multiply by 100, becomes 10 times bigger or 100 times bigger, right? So our model showed us that finding 100th of something is like finding 1/10 of a tenth. So we have to shift 1 place 2 times. All right, so we have to move. We have 2 numbers behind the decimal, and we're going to shift this once, twice, right? We're going to shift this once, twice, and if we had a tens here, we would be there is 0 here, we would be shifting it over. So we would end up with 1, 0, 0.0. So 1/1000th is the same as 0.001. Are you following along? How are you doing? All right. Are you understanding? So do you see why necessarily it's not really the big idea to use this, because that would be too hard, but just to look at, just to remember how we were shading in one direction, shading in another direction, and our double shaded was our answer. All right, now we have 0.5. So when I write 0.5 or 5/10, where will the digit be in a place value chart? It would be in the tens place, right? So what will happen when we multiply by 100? 100th. So now I'm multiplying by 100th. It'll be 5/1000ths, right? Because I'm multiplying 5 times 1 and it becomes 5/1000ths. So if I wrote it like a fraction, 5/10 times 100th, I would end up with 5/1000ths, wouldn't I? What would that look like as a decimal? 0.005 tens, hundreds, thousands, right? All right. Now, here's another problem for you. I want you to express solution, find the answer, express 1.5 as a fraction greater than 1. What would this be? 1.5. What would 1.5 or 1 5/10 be if it were a fraction greater than 1? It would be 15/10 because it has to be a fraction greater than 1. How many times will 10 go into 15? Once. What's left over? 5/10 or 5/10, right? So 1 5/10. All right. Now, let's write this as a multiplication problem. All right, let's write 15 tenths times 1/100. What would that become? 15 thousandths, right? So what does 15 thousandths look like as a decimal? Well, it's 0.015. So the 5 has to be in the thousands place, and the 1 is going to sit in the tens place. Okay? So that's how you make sure that when you have double digits, that you have your digits in the right place value. So 5, it has to be in the thousands place. So I make sure my 5 is in the thousands place, and my other numbers simply fill in from there. All right. So now, problem 4. Write this down. So I'm going to write this problem expressing the decimal as a fraction. So I'm going to write this as a fraction. So what does that look like? 7 times 2 tenths. Are these equivalent expressions? Is this the same as this? Yeah, it is. Because 0.2 or 2 tenths is the same as 2 over 10, 2 tenths, right? So when we multiply, what will the numerator show? What will the numerator show? Well, the numerator is going to be 7 times 2, right? Which will be 14. And what will the denominator show? It will show 1 times 10, right? Which will be over 10. So now we have 14 tenths, my friends. I want you, what do you think? So this is our solution, 14 tenths. But I want you to write 14 tenths as a decimal. What would 14 tenths be as a decimal? Well, you can think of it this way. 10 goes into 14 how many times? 1 whole, right? And what would be left over? 4 tenths would be left over, right? So 1.4. So think about what we know about the place value chart and multiplying by tenths. Does our product make sense? Sure it does. 7 times 2 is 14, so 7 times 2 tenths is like 7 times 2 times 1 tenth. The answer should be 1 tenth the size of 14. It's like 7 times 2 equals 14, and then the digits in 14 both shift 1 place to the right because we took only 1 tenth of it, right? So we shifted it, right? 7. So we're going to have to move. So I know it's like 2 tenths copied 7 times. It's 2 tenths copied 7 times. So 5 copies of 2 tenths is 1. And then I added 2 more copies of 2 tenths. Or you can think of it as simply simplifying a fraction. 10 goes into 14, 1 whole, and what's left over? 4 tenths. All right, moving to problem B. So I want you to start off with, what does 7 tenths times 2 tenths look like as a fraction? Well, 7 tenths times 2 tenths is 14 100ths, right? So 14 100ths, what does 14 hundredths look like? Well, remember, our 4 has to be in the hundreds place, and the 1 has to fill in front of it. Correct? correct. All right, can you solve 0.07 times 0.2 or 7/100 times 2/10? First, what does it look like as a fraction? Then, how would you turn your fraction into a decimal? Go ahead and try that out. See what you get. So you would get 7/100, right? Times 2/10 is equal to 14. What? 100 times 10 is what? 1,000, right? So now, what does that look like as a decimal? So, okay, let's think about it. 4 has to be in that thousands place, right? So 0 point, now I have tens, hundreds, here's thousands. 4 has to be in that thousands place. 1 has to be in front of it, right? In order to be 14. So 14 thousandths is your solution. All right, you guys, that is it for our concept development on lesson 17. What your job is to do right now is to take on the problem set. So you're going to go to the problem set now. Lesson 17 problem set. Now, you do not have to use these hundreds charts, okay? What you can do is simply do what we've been doing is you're solving and you're going to solve and express everything in a decimal as your answer. And if you want to use a place value chart instead, you can. So we have 1, 2, 3. If you want to use this, of course you can. Then on the back, multiply. The first few are started for you. So it's started. You need to complete the solution and go ahead and solve the rest of those. Then problems 3 and 4. A Boy Scout has a length of rope that measures 0.7 meters or 7/10 of a meter. He uses 2/10 of the rope to tie a knot at one end. How many meters of rope are in the knot? What do you think? How would you solve that? He uses up 2/10 of it. So I want you to go back to what have we been doing with our decimals, right? We're multiplying in this lesson. Okay, just 4/10 of a 2.5-mile race was completed, Lennox took the lead and remained there until the end of the race. Okay, just after 4/10 of a 2.5-mile race was completed, Lennox took the lead and remained there until the end of the race. So how many miles did Lennox lead the race? So 4/10 of, right? Reed, the second place finisher, developed a cramp with 3/10 of the race remaining. How many miles did Reed run without a cramp? So go back to what we've been doing and what you know. Go back to what you know is what I always say. What have we been doing? How have we been solving these problems? So go ahead and complete the problem set and then come back and check part 3 of this lesson where I will have gone through and solved and I will explain to you how I solved everything. And this way you can check your work so that when you go to do the homework, you know you're on the right track.